Hi, and welcome to the lesson of differential equations. So in this class, we are going to start second order differential equations. So we will be specifically talking about ordinary differential equations. So this is the lesson on the second order ordinary differential equations. So the general form of second order uh, linear differential equation can be written as d squared y over d x squared plus b of x dy by dx plus c of xy equals some function of x, and therefore these a of x, b of x, and c of x and f of x are just functions of x, and if we have constant terms here instead of functions, then we can say that the equation is with constant coefficients. For instance, if we just write this as in this form, that is a d square y over dx squared plus b dy by dx plus c y equals to, let's say, 0, then this equation is homogeneous with constant coefficients since a, b, c are constants, right? So this is the general form of second order differential equation. So we may have an equation that is homogeneous and linear homogeneous with constant or variable coefficients, constant or variable coefficients. Since for now we are only dealing in the equations of the kind with the constant coefficients, and therefore later on in this subject we will also talk about the equations with variable coefficients, right? So let us consider an equation and see how to solve. So let us uh, have this equation d squared y over dx squared plus 3 dy by dx plus 2y equals 0. So it's a simple linear homogeneous differential equation with constant coefficients. So we can write this in the operator form. That is, we can write this d by dx as d, then similarly d squared by dx squared as d squared, right? So these are the operators applied on the functions. Therefore we can again write it as d squared plus 3d plus sorry, it's 2 here, so it's 2y plus 2 applied on y. Since this is an operator, so it's not a multiplication, it's not an ordinary multiplication, it's an operator that is applied on function. Therefore now we can break it like this: d squared plus 2d plus d plus 2 applied on y, and then further we can simply uh, write it in this form, that is the factor form. So we will have two factors of the operators, one as d plus 1 and other as d plus 2, and this is applied on y equals 0. Now since we are interested in solving this equation for y, we want to find y equals to some function of x. Therefore we need to find this function. So what we can do here is that an operator is applied on an operator is applied on a function. Therefore we know that when this operator will apply on this y, we will get some function. So we can write as assume d plus 2 operated on y equals v, therefore d plus 1 operated on v equals 0. And now since this is dv plus v equals 0, where v is a function of x, and now we can see that this is just nothing but a linear equation, simple linear equation, homogeneous as well, with constant coefficients. Therefore, by solving this equation, simply we can write it in this form, negative dx. And if we solve this equation, we will get negative x plus c. So v equals a e to the power negative x. So this is our v. And now if we move back here and see what we supposed earlier was d plus 2 applied on y equals v, therefore d plus 2 applied on y is now equals to a e to the power negative x. Therefore, this is again a linear equation, but this time it's not an homogeneous equation since we have a function on the right hand side, this function here. So therefore we can write it as dy by dx plus 2y equals a to the power negative x. Now we are familiar with solving these kind of linear equations since we need to find the integrating factor that will be equals to e to the power integral of 2 dx. Therefore e to the power 2x is the integrating factor, and multiply with this equation. So we get a e to the power negative x times e to the power 2x is simply the left hand side is now e to the power 2x times y operated by this operator here, and this will be a to the power x. Now we can simply integrate here and we'll get the result. So it's e to the power 2x times y equals a e to the power x integral. So e to the power 2x times y equals to a e to the power x plus b. And if we move e to the power 2x to the right hand side, we get this thing here, b e to the power negative 2x, and y equals to a e to the power negative x plus b e to the power negative 2x. And this is the solution of the given differential equation that we earlier stated over here, and this one. So you see how we can solve these kind of equations, and in the next class we will start solving equations with some more different properties, and then we will go to the formation of the auxiliary equation or the characteristic equation. So we will avoid this lengthy procedure and simply use the auxiliary equation to find the roots and then find the solution for the differential equation. So thanks for watching the lesson.